In this video, I'd like to talk about the math question of the day for March 18th, 2023. And for this problem, we need to simplify this expression here, which will use various different exponent properties. So to answer a question like this, you do need to have a solid understanding of pre-algebra and the exponent properties you learned there. But we also do have a fractional exponent, which is something that's typically taught either at the very end of grade school or in Algebra 1 or Algebra 2. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, we can go through this together. Now, assuming that you have attempted the problem, let's start working on this. And if you do have suggestions for future questions of the day, feel free to leave those as comments. Now, with exponent properties, we will need to know what fractional exponents mean. We will need to know what happens when we take a product and raise it to some exponent. And we also need to know what happens when we take an exponential expression and then raise that to some exponent. And at the end, we will need to combine these two exponential expressions that are multiplied together. So we will need many different skills to deal with this. And let's start simply. We can deal with this exponent to an exponent. And we know that when we have x, let me use a different letter actually since we're using x. Let's say when we have a to the b power and we raise all of this to the c power. When you raise an exponent to an exponent, you multiply the two exponents. And keep in mind that all exponent rules make sense. You just need to understand them from their basic properties. For instance, if we had, let's say, 2 squared and we are cubing that. Well, on the inside, 2 squared, this is just 2 multiplied by itself twice. And then we're going to cube this expression, meaning we are multiplying this 2 times 2 by itself 3 different times. And what you'll notice is that you end up with 6 2's multiplied together, which we can rewrite as 2 to the 6th. But if we just applied this rule, we're raising an exponent to an exponent, we multiply the exponents. 2 times 3 is 6. So you can see that the rule makes perfect sense if you just remember the basic principles of what exponents actually mean. We are taking this expression and multiplying it by itself this many times. So we can start by simplifying this to x to the 15th power, since we have an exponent to an exponent, so we just multiply there. Now, this one is a bit more complicated because we have a product that we're raising to a power. So let's look at that rule. Let's say that we have d and we're multiplying it by some other number or expression e, and we raise all of this to the f power. Then this exponent will essentially go to each factor in this product here. We would have d to the f multiplied by e to the f. Now, like I mentioned with this rule, all exponent properties make sense, and this one does as well. Let's look at a specific example. Let's say we have 2 times 3 and we are raising this to the 4th power. So we're multiplying this expression 4 times, and if we just use the rule, we would have 2 to the 4th multiplied by 3 to the 4th. But we can see that makes sense because we're multiplying this 2 times 3 4 different times, and when you write it out like this, you notice that you have 4 2's multiplied together, or 2 to the 4th, and 4 3's multiplied together, which we can write as 3 to the 4th. And you can see that the rule makes sense. So we can apply that here. Each factor will be raised to the 6th power. So this would simplify to 4 to the 6th multiplied by this exponential expression, which is x to the 5/2. And we're raising all of that to the 6th power. In some sense, the exponent is distributed to both of these factors here, but it's not the exact same thing as distribution. So you want to be careful just memorizing that. And I encourage you to think of these rules with their basic principles. Start with an example and make sense of this rule for yourself. Now, the last thing here before combining these two expressions, we need to deal with this fractional exponent. So let's make a little bit of room. We need another exponent property. And if we have, let's say, g raised to the h over k power, then the denominator tells us what root we are taking of our expression, and the numerator just tells us what power we're raising that to. And we could have written this another way. We could take the kth root of g and then raise all of that to the h power. So as an example, let's say we have 8 raised to the 2/3 power. And like I mentioned, the denominator just tells us the root we're taking of the number, and the numerator tells us what we're raising that to. And if we wanted, we could have done it the other way. We could have taken the cubed root of 8 squared, and both of these expressions will evaluate to the same answer. In both cases, we would get, well, the cubed root of 8 is 2, and we're squaring that, so we'd get 4. And if we did it this way, 8 squared is 64, and the cubed root of 64 is 4 as well. So before we look at the fractional exponent, notice we have an exponent to an exponent, so we'll apply the same rule we did here. We will multiply those exponents together. And let me make a little bit of room so that we can work down here. And let's start by just rewriting everything. We have this 4 to the 6th multiplied by this exponential expression raised to the 6th power. But we know since we're raising an exponent to an exponent, we multiply. And 5 halves multiplied by 6. Well, 6 over 2, that's 3, and 5 times 3 is 15. So we get x to the 15th power, and we won't actually need to deal with these fractional exponents since we eliminated the denominator here. We were able to simplify this. So from here, we are multiplying everything by x to the 15th. And the last exponent property that we need is if we have, let's say, m to the n multiplied by m to the, let's go with p. When we have two exponential expressions multiplying and they have the same base, we just add the two exponents, n plus p. And again, this does make perfect sense. If we look at an example, let's say we have 2 squared multiplied by 2 cubed. You can think 2 squared, that's just 2 times 2. 2 cubed is really just 2 times 2 times 2. And notice that you have 5 2's multiplied together, which is 2 to the 5th. But if we just applied the rule, 2 plus 3 would give us 5. So we have the same base here, and that means we can just add the exponents. And again, this should make sense from another perspective, since we have 15 x's multiplied here. We have 15 x's multiplied here, so in total there are 30 x's multiplied together. And our answer would be 4 to the 6th multiplied by x to the 30th power. And if we want, we can actually evaluate 4 to the 6th, though it will be quite a large number. This is really just 64 times by 64, 4 cubed multiplied by 4 cubed. And we would get 4,096 multiplied by x to the 30th. So this right here will be our final answer. And one way you can check this, and it is a bit tedious, is to pick some value for x to actually plug in here. Maybe set x equal to 4 and evaluate this expression. And then go down to this expression here, set in the same x value. And if you get the exact same answer from both of these, then you know that this expression here is equivalent to this expression here. But that, like I mentioned, is a bit tedious, and I will leave that as an exercise for the viewer.